I'm very excited to be here at Trino Summit. Me and David here talking about what I call FLiP into Trino. We have a bunch of slides here going over some of it, and I've got some demo with a couple of ideas of where we use Trino. Obviously, you heard of some exciting things happening that adds yet another angle there, but there's a lot of different ways Pulsar and the FLiP stack work with our favorite small fuzzy animals, though we like the squirrels too, all the cool mammals out there. So let me get in here. We kind of mentioned Stream Native. We do Pulsar and Bookkeeper and a little Flink there. I want to introduce David. If you want to talk a little bit about your background, David.
Sure. Hi, my name is David Kermgaard. I'm a developer advocate at Stream Native. I'm also the author of the upcoming book Pulsar in Action by Manning Press. I've been working at Apache Pulsar committer, working on the project for over 4 years.
So that's pretty cool. And that book is available very shortly. As you see, I have a little fun going on here. I'm a developer advocate at Stream Native. I do some blogging. I do a lot of different technologies around streaming. And I love all the really cool projects out there in the open source. I'm a big open source person. So I put together what I call the FLiP or Flippin' Stack, and today, to make it more specific, it's the FLiP into Trino stack or the Flip It stack, because we've got Flink, we've got Pulsar, we've got NiFi, we've got Trino. All these projects work together extremely well to solve some pretty complex problems and make them pretty easy. Now, I'll show you a couple ways that Trino's in there, and I'll have David, because he is, the expert and has written the book literally, and it's a pretty awesome book that on some of the background and some of the things on Pulsar. I'll show you some of the places where we're interacting with Trino, show you a demo that I have running in my little environment here on what happens when data comes into Pulsar, how I could use the Trino under the covers against it with SQL, how I can get data into and out of Trino as part of some of these applications, whether they're streaming REST data, IoT data, events. Trino fits in really nicely for what we're doing in this, modern cloud native data stack that we have. Pulsar, I'll hand this over to David in a little bit once we get into the more interesting parts of Pulsar, but I want to go from the top part so you know who we are and what we're doing. Open source, as you can see with Apache, but cloud native, distributed messaging, and streaming. And those are not the same things. If you were on our little Twitch session yesterday, we went through it, but here's a little more on how those are different, but how Pulsar unifies those together. When you're doing messaging, you may be using ActiveMQ or IBM or SQS, lots of different ways to do messaging. These are sometimes for work queues, sometimes just to move messages quickly. Some of these are in some legacy apps. Some of these you just can't change. But what's nice is Pulsar can handle those messaging styles of, maybe you want 10,000 consumers. As soon as they get a message, just process it. But then on the other hand, you might have, Kinesis style workloads where you're doing data streaming where it's event at a time and order is either critical or very important. You worry about, things like exactly once semantics. Pulsar has you there too. So that's really nice that you could do both kind of features there. David, you want to walk our friends there through some of the awesome features of Pulsar?
Sure, absolutely. Thank you. Thank you for that introduction, Tim. So Apache Pulsar, as Tim mentioned, is a distributed messaging and streaming system. It's built on a multi-tiered architecture. So it has a separate serving and storage layer. The storage layer is implemented as Apache Bookkeeper under the covers, and that's where the Trino connectors sort of plug in. They can query that data directly. so that you can access that data without having to go through a messaging API. So in addition to all the different, messaging semantics that you get and processing you get like Apache Kafka and RabbitMQ, you also have the ability to have, tiered storage, persistently offload the data to S3 buckets, things like that, and still query that data, access that data natively, because the way it's stored in address is really just a URL. And to Pulsar or Trino, it's just another hop, and then you could go access the data as it's stored. Obviously, there's multiple different, programming languages supported. It has multiple subscription types to support all the different streaming and messaging use cases. And it's not limited to a single messaging protocol either, which is very critical. So not only can you run it on any cloud, but it can speak a lot of different common messaging languages, including MQTT for processing, event data on the edge, AMQP, which is your traditional RabbitMQ sort of protocol. So you have existing applications in that you can easily migrate over. Also, likewise, things for like JMS or Kafka, and that list is expanding as new protocols come in. We'll support it as well to speak those languages natively. So, yep, and it's also infinitely scalable because each storage layer is independent. They can scale independently of one another and handle any sort of load that you're having to throw at the system.
Yeah, and I think that multi-protocol support really helps you out in a lot of these different applications you're doing. So you don't have to rewrite existing apps, especially if you have devices that maybe only do MQTT or maybe only do WebSockets. The amount of different protocols you could do, so you don't have to worry of, is there a client available on some weird architecture I have? Is it there? If it's not, use one of the other protocols. It's, pretty awesome thing there. David was talking about some of this here. If you want to go a little deeper on this, David.
Sure, absolutely. So again, it consists of the Apache Pulsar framework, and a traditional cluster consists of 3 separate components, each powered by its own open source project. So again, Apache Pulsar brokers at the top is the serving layer. That's where all your producers and consumers interact with the system. That handles all the message routing and connections. It's completely stateless. And it has automatic load balancing as well. So any broker can serve any topic at any given time, because the data is not stored with that broker, which is unlike other messaging systems that pin the data together in order to get some efficiency as far as data serving and data access. The architectural trade-off is made to have a separate tiered storage layer, which is powered by Apache Bookkeeper there at the bottom. Within each one of those Bookkeeper is what's called a bookie, and those are a stateful storage layer that it works on an append-only distributed log concept, similar to Apache Kafka or other messaging systems. They're stored in ledgers called what's called ledgers, and then they get replicated across multiple bookies so that the data is always available. And you can have placement policies as well to make sure that copies of the data are in different racks, different availability zones, however you want to share that data distributed. And then the last piece is Apache Bookkeeper, which is used to keep metadata about what ledgers within Bookkeeper, what segments within the cluster itself. For example, a good example that would Apache Bookkeeper constitute a topic, and so that information is kept inside of Apache Bookkeeper, and it's only used very, very infrequently, unlike other messaging systems that rely on it heavily. It is completely used very sparingly, and there's a project as well to completely eliminate that and have it put inside the Apache system as well. So that's an ongoing project as well.
Yeah, I don't think that's not a major part of the structure. I think the important part for people thinking cloud native is being able to scale Pulsar brokers separate from storage brokerage. That's huge. I mean, you tend to have a lot more compute than really have to worry about these storage nodes. Also makes things more affordable in my mind, that you don't have to spin up these giant nodes or pods somewhere because you've got all that storage you got to worry about. So that's pretty nice. There's a lot of syncs out there. I just want to quickly mention a couple. If you're interested in, maybe I don't want to have to write code all the time. Pulsar has a lot of different syncs built in. So once I get data into a topic, I could, have it automatically stream out to Mongo and to Lambda, Redis, S3, ton of different ones out there, all the cloud storage. Makes for a very easy way to, as soon as something's in a topic, get it sent somewhere while it's still, stored permanently or for as long as you want. Topics don't have to be persistent if you don't want to, but with that ability to send that out to tiered storage, which could be much cheaper than storage on a node. You don't have to get rid of data and then having that Trino SQL underneath there. So if you do have all that storage in there, you could query it with a modern, fast query engine. Makes for a really nice way to have a streaming messaging system. I don't know if you want to go through a couple of quick points on the APIs here. I think differences between publisher and subscriber might be of interest to people.
Sure. Yeah. Thank you, Tim. So the middle, sitting there at the middle, is obviously Apache Pulsar, and surrounded by those boxes are the various different APIs or ways that you can interact with the Pulsar platform. Right. So the PubSub API is traditionally used by things like microservices or your traditional applications that want to do, stateless processing of events. A work order comes in, you delegate it off a work queue. It sits in a work queue. Somebody takes that piece of data, and then it has all the information it needs within that piece of data to do its work, and it does that unit of work, and then it's done. So that's the PubSub API. Their way to traditionally send messages back and forth between systems. At the top is the reader and batch API, and that's traditionally used by stream processing tools, things like Flinks, Spark connectors that can go back to a point in time and read the data from a specific topic in sequential order, in the time order that it was arrived and processed. And that's again for more stateful processing, doing more detailed analytics, things like that on, computing averages, sums, things like that over longer windows of time. There's a third piece is the administrator API, which has some different ways to, create, not only, manage the cluster, do tenant level application as well, because Pulsar is a multi-tenant system, meaning that you can support different organizational groups within the same piece of, the same software, without having to have a different cluster stand up and, have different, in order to ensure security and people don't get access to the data. Traditionally, in other messaging systems, you have a separate instance for each. Pulsar supports that through the use of tenants. Then at the bottom is what Tim mentioned around the Pulsar IO connectors, which is a specialized stateless serving layer that handles, the ability to interact with external systems such as Trino, S3, Redis, etc. And they consist of both sources and sinks. So you can have data tap into these existing systems to bring it into Pulsar, or you can do some processing of the data within Pulsar, some stream processing, dump it back in, and then have a sink, flush it out, and write it to your third-party system. So in this case, Trino could be both a sink and a source, depending on how you want to look at it, how you want to use it.
Yeah, I think we gloss over something that's such an awesome feature for people coming from different systems. The tenant and namespace set up for Pulsar makes things, to me, one cluster to rule them all. I could have one cluster for my organization that supports, everything I need to do and keep things, completely separate for different teams or organizations. Wherever you want to set that up, having tenant namespace and topics, as many of those as you want. So really nice feature that we kind of go like, oh yeah, tenants. Other people don't have that. That turns out to be a really helpful thing. The same thing with having multiple subscription modes for getting your data. If you want to tell people why that's such a big deal, David.
Well, sure. There was a question in the chat that came up about are there plans to remove Zookeeper? That's fine. I addressed that in passing, but yes, there's a roadmap. If you watch our product roadmap, there was a webinar by our chief product officer 2 days ago, and it's on a roadmap to remove it in the next quarter, in upcoming quarters. Within 6 months, we'll have a completely Zookeeper-less Pulsar instance available and running. So yes, that's a great question. It's something we're moving to eliminate, similar to what Kafka does. Now to talk about these subscription modes that Tim mentioned. So there's really all the data is stored exactly the same within Pulsar, right? So it comes in as an append-only log. You keep these items in a list, sequentially stored in the order that they arrive. But the processing semantics and how you decide to consume those messages really dictates whether it's a pub sub consumer mechanism or it's a streaming mechanism. And how that's implemented in Pulsar is through this concept of called, the subscription modes. Now at the top is something like exclusive, which is just like it says, allows a single consumer at a time. That implements the streaming use case. In this case, the consumer is guaranteed to get all the data and in the order it was given. And that's useful for use cases, again, like you're calculating an average or running an average of a particular, let's say, sensor data. You are required to have all that data. It all has to be delivered to the same consumer so it can do that calculation in memory and then compute it. And that's supported by what's called an exclusive consumer subscription. And next is a failover subscription mode, which in that it has, for those of you coming from a Kafka background, this is similar to what you call consumer groups, where you can have over allocated number of consumers, one per partition is all that's handled. But if you have more than one consumer, it sits idle. In the event that one dies, it immediately takes over from the spot that that one took, left off at. So it's really there for failover scenarios. But again, you have only one consumer at a time. Again, that's a streaming sort of use case. The bottom two, the shared and the key shared, are what implement the pub sub. And that allows multiple consumers. You can have as many consumers as you want consuming the data, and message is delivered on a first come, first serve basis. The first one that comes in and gets a message, consumes it. As soon as it acknowledges the receipt of that message, will immediately be given the next one in the queue, whichever one's available. And so there's no guarantee of, the messages are distributed across as many consumers as you have. That allows you to have high throughput processing. Again, if you have work queues or large volumes of data you need to process quickly, and you can do it in a stateless manner, then shared subscription is the way to go. And then we've added a fourth one recently called key shared, which has some of the semantics of streaming processing in that it makes a guarantee about, so if you assign a message, each message can be assigned a key if you want to. So again, let's say you're doing stock trades and you assign the key that is the ticker symbol. This subscription guarantees that each consumer will get that same key. So again, if you're tracking the Apple stock price, once the consumer has been given the first Apple piece of information, it will get all other Apple pieces of information, and only that one will get that. So you can have the guarantee that I'm getting all this data, but you can have multiple consumers spread out so that they can still, each one will get a subset of those keys, but they will get all the data for each key in their set and in the order that it was delivered. So this is a great use case, use case for things like clickstream analysis, where you want to make sure that you have the same data for the same user delivered to the same consumer, so you can do stream processing, stateful processing on it.
Yeah, that's again something we don't want to gloss over. That it is pretty powerful that you're not stuck to that. I'm going to skip a couple of these slides, leave them for later. Watching the time here, I want to make sure we get to the part where Pulsar and Trino are connected here. For me, this has proven to be a really useful feature. Being able to see what's in the topics right now and do that with a real powerful querying tool like Trino, and been able to use third-party products. So things that may be, hard to look at without consuming or writing an app to get the data that, is streaming through the system or is stored there for some period of time, perhaps forever, depending on what you want to do with tiered storage. Pulsar SQL lets us get access to all this different data, even though it's pretty complex the way it's stored with the what David's mentioned with the bookie nodes, potentially storage in external storage. Trino just digs into there, gets that data, and when you see how quick it is, I've been really impressed because there's a lot going on there, but it happens super fast. Again, we don't have to sell Trino to the people here, but the power that you could do here using that to be able to see what's going on with the data as it's coming through the system, maybe using it for dashboards, analytics. Obviously, this data has a lot of value. Otherwise, you wouldn't have ingested it real time. This gives you also a good way to see what's going on at that moment in time. The one thing I want to mention is the difference between what we do with Pulsar SQL with Trino underneath and what we do with Flink SQL. They have different use cases, both of them very valid, but different ideas here. Pulsar SQL we use against what's in the topic right now. Now, that's fine. We run the query and it's done. I get a dashboard. I put it in an app. Maybe I'm just looking to make sure my data's arrived. Whatever use case you might have there, that's what Pulsar SQL does. Flink SQL, I'm running a continuous query. As an event comes in, I want to do some processing on it. It's a different use case. It's not I don't want people to get confused that they're use one or the other. There's very specific reasons why you want to do that. From the command line built into Pulsar, very easy to spin up a SQL worker and then get into the SQL console. It's very interesting to me the way the data is broken up. What's nice is I go in there, all that metadata is set up for me. Under Pulsar are our tenants and namespaces. And under there, we have all the tables. The tables are our topics. I don't have to do any extra work. That is pretty awesome. I don't have to manually build tables or do mapping. It's just there. And if I use a schema in Pulsar, which is very nice that Pulsar has a built-in schema registry. If I built that schema when I put the data in, all those fields from the schema with their type are automatically in there for me. So I could easily do my queries. Makes it very nice here. I'm going to skip through a couple of those that, you'll get when you get the slides, being cognizant of time. And I want to show you some demos and maybe answer some questions if we have some at the end. But what's nice here is easily the command line's built in for Pulsar, so I could easily get to an embedded Trino to query it. Now, we can also use an external one if you want. If you already have a big cluster out there, no reason to have a separate one. I do in my demo have two separate ones because I have a newer Trino cluster that I'm using for storing some of my data in, but that's unrelated. Having the access to that REST API makes it very easy. Having the ability to see the namespaces and tenants within Pulsar, really nice. The syntax takes me a little bit to remember. It's Pulsar and then quotes and but it's once you start doing it, the queries there are pretty powerful. You've got all the SQL that you need. I don't want to spend forever on the slides. I want to quickly show you what I'm doing, and then we'll get to some more slides and some answers because I want to show you this in the real world. And let me start off with everyone's favorite command line. I have an NVIDIA device here that I'm going to run to get data flowing into my system. It is pushing it into Pulsar two ways. In one way through MQTT, that's the broker adapter there, and the other way is going to be right through directly to a Pulsar topic. One is going unstructured, one's going structured, and then we'll be able to see the data. Here I'm connected to the internal SQL, unless my thing timed out there, and I could just query what's in those topics, while that data is streaming in. Let's make sure our thing, I started getting some data here. We're getting the data back from there. Only 3 rows in there because I just started building it up, but gives you an idea how easy it is to navigate the data with SQL here. There's other ways to do this, obviously. I have dbeaver here, which is a great way to navigate through. Here is the one that's embedded within my Pulsar cluster, and I could see all the topics here. This is the one that's I'm putting data into now. Here's some other topics. Again, shows up with tables. If I can query it here through the JDBC driver, I could do it through an app. I could do it through a dashboard, do it through notebooks, wherever it makes sense for you to access this data. Probably going to do a Spring Boot app on this later, but pretty cool. Very easy for me to query those topics. It looks just like a regular table there, nothing unusual. And then I'm going to show you over here, I'm pushing data into Trino using NiFi, pulling it from Pulsar. NiFi is grabbing it thanks to David's really cool NiFi processor for Pulsar. But let's get to that. Let me make sure I have all my data running. Here I'm querying some of the data I put into Trino. Pretty easy to do. I have a NiFi cluster here where I'm pulling data from Pulsar and pushing into Trino. It is about as easy as can be with those 2 steps. Again, multiple ways to do that. What's the minimum Pulsar version with stable support for Pulsar SQL?
I can answer that one, Tim. So
there you go.
that has been around since version 2.4, which is very old. That's almost 2 years old. So it's been around for 2 years. I would say I'd recommend using a newer version, but you can get as far back as 2.4.
Very cool. I would say take a look at 2.8. There's a lot of good features here, a lot of good performance, cool stuff going on there. So as easy as possible to grab data from Pulsar, put it into Trino with something like NiFi or Spark or Flink, very easy to connect between these. I'm pushing data here into Pulsar, and as it's going into Pulsar, here I'm pushing it into Trino. These could be in separate clusters, different clouds. Just shows you how simple it is. Once I have data from wherever it is, here NiFi is pulling it in from a weather service. I'm processing, cleaning up the data, getting it into Pulsar. Again, I just need to know the topic, have a connection to my cluster, and the data is streaming into Pulsar. And then once it's in Pulsar here, I could have someone read it and push it into Trino. Pretty straightforward. And on the other end, I could query data from Trino if I wanted to do some other processing with it. Very easy to do that with NiFi or anybody who works with JDBC. Pretty straightforward here. Also have some other use cases where I'm, again, pushing to Pulsar, maybe consuming from Pulsar, push somewhere else. Very easy to do this. Not complex to be able to send data at extreme rate to wherever it needs to go, and do that without writing any code. I could add some Pulsar sync, some Pulsar functions to do additional processing, and then just consume that from wherever it needs to consume. Having a fast data store that I use for both internal analytics and external analytics for the data I'm working with. Pretty awesome. I'm watching a screen here, watching all those records go into Trino, which is pretty cool. Let's get back to the slides. Now, I'm running this in an environment that I set up. It's a lot easier if someone else does it for you. I mean, as we know with the cloud, making sure things are stable, monitored, metrics, all that running. It's better to have someone give you a hand there. Fortunately, Stream Native has a cloud system to make this a little easier to run these at scale and make that very easy, and run that on top of all the major clouds. Run that on top of Kubernetes, again, cloud native modern architecture, and have things like Flink in there to be able to help you with the stream processing. Pretty straightforward. And we just won an award which is pretty awesome. But we wanted to talk about use cases. Oh, David, you want to answer this question before I go into use cases?
Sure. So the question is, what is the maximum amount of time that will be taken by Trino to query the child hierarchy? The child hierarchy levels in JSON. I haven't really quantified that. I do know that it can query multiple different levels, and it does add some additional time, but I do not have an official sort of metric on that. We haven't really tracked that metric, so I can't really give you a definitive answer on that. The performance is not, significantly different. So how this is implemented, this is implemented is Trino, at the time Presto, now Trino, provides an SPI or service provider interface that all you have to do is provide how to tell an interface that tells Trino how to read the data once it accesses that data. So when you issue a query to the distributed Trino processing engine, what we return back is a list of these ledgers of where the data is, and then it scans those in parallel, knows how to open one of those, quickly read that data because it's a distributed log, parse each one of those for information, and then collate those results back. And so that's how it actually works. How many child hierarchies does Trino support for drill down? As far as I know, it's only limited to what the actual Trino plugin itself supports. As far as I know, it's that's the limitation on that. So I don't have a number on that either. Lastly, what is the role of Trino in querying streaming data warehouses? So as Tim mentioned, it's more for querying historical data, the static data that has been theoretically offloaded and put in stored in persistent storage versus having to continuously updating streaming engine. So it is a great fit for processing static data that has already been coming in to your warehouse and processed. You want to do averages and summations and counts and things like that across the data over the last n amount of days and amount of hours. That's the perfect fit for that. Whereas if you want to have a continuous data, what's the most recent one of the most recent data, then the FLiP SQL engine sort of is a nicer fit for that use case. So they both play very nicely. Presto Trino does the heavy lifting of the historical data. FLiP SQL is better fit for the real-time continuous streaming on that. So I'll hand that back to Tim for the use case.
Yeah, when we talk historical data, it might be from 1 second ago.
Yeah,
so
yeah.
Don't think of ancient batches. Trino is doing some fast stuff there. So that's where the use cases to me make sense when you need tremendous scale. So that we're talking high volume sources. IoT is a common one because things in IoT could scale out really large. I might be getting data in from thousands of devices, and whatever you think of as a device, it could be a cloud endpoint, could be logs, could be your smart refrigerator. There's a ton of data out there coming in different formats, maybe different protocols. This is ideally suited to my FLiP stack of FLiP is probably in there to do some stream processing, but I need Pulsar as my mechanism to get that data around and available. And then I need a very scalable data store, because once you start talking these volumes, something flexible like Trino makes a lot of sense. Some other common ones that I've done here that really marry well with this architecture, things like live transit data, live news feeds, things like Twitter, social media, where you have a ton of data, semi-structured, structured. It may change, it may be sparse. These things all fit in nicely with this kind of infrastructure. And this is a common one for when I'm running, lots of different devices in. Some of them can only talk some protocol they've been pre-compiled for, like MQTT. Some might have very limited library access. So maybe I have to do something like a WebSockets to get to Pulsar. Maybe I need to have a gateway before I connect to Pulsar. Something like NiFi or Minify works there. Sometimes I might directly send my data into Trino. Very often I'll go through Pulsar so I could distribute it, because maybe my Trino cluster is in the cloud and I'll have, some regional or gateway Pulsar clusters that are geo-replicated around the world. And then I'll get my data into Trino, and then using Trino internally to be able to query my data stores. Lots of different things there. That's a pretty common architecture. I did the demo early because I know time goes fast when we have questions and all those other things. We'll give you all these slides. I know the videos will be available later. There's a ton of examples, demos, and source code I put out there, so you'll be able to run these all yourselves. I put some static images in the code, so you don't have to be flipping out, trying to find the stuff in GitHub while you're looking through the slides later. One thing I wanted to show you, when I showed you those queries in Pulsar SQL, the way to get it so I have all the fields is to have a schema. So when I'm pushing data into a topic, you got to do a little extra work. I see, Brian, we're probably getting pretty close.
You got some time left. I just wanted to hang out here for a second. Keep going.
Okay. I got the bunny on my shoulder now, so I'm like, oh. You got those eyes looking behind you, the time and the clock running down. So here, the thing to make it easier so that I get all that schema in there, it's not hard to add a schema here. This is an example, small Java program, but you could do it in Python, Go, lots of other languages. But the main thing is to get it, all your fields mapped up. Again, not much to it. Once I send it with a schema, it goes in the schema registry. Internal Pulsar SQL can now get all those fields, so it makes it a lot easier to do it. It's very easy to sync data into Trino with JDBC, the nice JDBC out there. I did that in like an hour. NiFi made it very easy to sync that into JDBC store there. Very easy to do that. And nice to run that. Very easy. All the parameters there, very easy to set up and connect to Trino. Depends on your security. I ran this in Docker, so I didn't really worry about security. Obviously, in the real world, you're going to care about that.